Alright, so this lesson is on 6.2, examples of automated manufacturing systems. So I've got a Prezi here which has a lot of videos in it, and I have listed the videos or placed them into our OneNote so you can access them as we go. But I'm not going to play the videos through this. You won't be able to hear them because I'm talking through a mic. Also, it would be wise to have your textbook open at the 6.2, which is what I'm talking about today. So let's get into it. So the topic is 6.2, examples of automated manufacturing systems. Now what that means is how in which manufacturing systems operate, and we need to make sure that we understand the different types of manufacturing systems that are automated. So the first one is, of course, assembly line production, and I could just simply Google an image of an assembly line production and get an image of what that looks like. We see quite often photos of the Ford motor car manufacturing images. The reason is that Henry Ford, who created the Ford motor industry, was the first to realise that if you created an assembly line, not only could the production of cars be much more efficient because you're assembling down a line, but also it dramatically reduces cost because the materials are already produced, and because of the time efficiency, it is a far greater efficiency of doing something. Now, assembly line production is where you can see here the factory workers are just simply, it looks like they're manufacturing a wheel, or maybe they're putting some bolts on the wheel or something like that, so that the product moves down a line, and that's why it's called an assembly line. So it gets assembled on that line. I know I'm stating the obvious, but hey. I do have a video here, which I'm going to skip in the Prezi, but it is on the assembly line of an Xbox, so you get to see how the inner working parts of an Xbox are created. And you will also notice that you should be able to draw a block diagram of the assembly of an Xbox, because it was the same as what was in the textbook, which is the assembly of a system box or a computer box. So I'll just skip that video. The next one is what's known as programming logic controllers, or PLCs. PLCs are where something comes along, say an assembly line, and a sensor makes a decision about what has to be produced or what has to be done at a certain station. Now, the video here in the Prezi that you can click on just shows blocks being moved down this line, and the sensors here are looking down at that. They're actually making a decision about what to do with that, whether it goes to a different station or whether it's stamped or whether or not it's left alone. These are the things that it needs to do. Now, in this video, it actually explains what a programmable logic controller is. So you can watch that video, or you can simply just type it into YouTube, because it's just a YouTube video. So I recommend that you pause this video now and watch both those videos so that you understand what programming logic controllers is, and also it would be wise that you take some notes on programming logic controllers as well. But I'm going to move on. So pause this video now and then come back to me. Alright, so the next one is automated warehouses, and automated warehouses are in which there is very little to no human interaction. You still need human interaction in any automated warehouse. There is always something to do. And I guess it's a point here where I need to stop and just say to you to talk about jobs and a thing called the nature of work. Automated manufacturing warehouses, in the HSC, it is stated very clearly in your textbook that no one will lose a job. And it's very wise to not mention losing your job because of automation. What you do say is that it changes the nature of work. So if we have someone who's actually working on an assembly line, then because they're employed, they would, and there's a number of reasons, why they wouldn't lose their job. Unions would get involved, and so what the companies tend to do is retrain their staff to do something else rather than them actually losing their job in an automated system. So automated warehouses, there are a number of reasons why we have them. A big one, of course, is for safety, where things can be done. And there's a lot of videos online which talk about industrial injuries caused by robotics, the automated process of robotics actually injuring a human because the human has got involved in the interaction of the product. We will talk about safety when we get into the social and ethical issues, work health and safety information, but we're mainly talking about the introduction of automated warehouses and what they do. So in a nutshell, they are really automated, obviously, in everything that they do. So collection of inventory, storing of inventory, sending of inventory, or the production of a product. They are really automated. So there is a video here that it's been made unavailable. So what I did was I actually went and grabbed a new video which talks about 5 fully automated warehouses, so you can have a look at that on YouTube. So it only goes for about 6 minutes, so have a quick look at that one as well. Alright, so just the things about automation, they can do things like order parts, they can monitor the weekly use of a part, know which products are not being sold, calculate capital tied up in a warehouse, assemble customer orders, and knowing what space is available for new products and ranges. So there are some notes that you can take down as far as the information about automated warehouses. The next one is CADCAM. Now CADCAM stands for computer-aided design mixed in with computer-aided manufacturing. So what, in a nutshell, this means is that you have a design, and usually the design is created by an architect or even just simply an engineer for a product that needs to be manufactured. They usually design it on computer, and well, most of the time they definitely do. They design it on computer, and then it is sent to a machine that can actually machine or produce the product. A classic example, and normally what I would do at this stage in my teaching is go to before our lesson begins, I would actually go and set up a 3D item to be printed. Just anything. It didn't, it could be a chess piece, or it could be just a simple die that could be 3D printed. Or most recently, I have been doing setting up the laser cutter, showing a design on the computer, and then laser cutting that so that I can show the manufacturing process. So the computer-aided design is done there, and then of course you take it to the laser cutter and then get it cut. So what does that look like? Well, I have a piece of software here which shows you, I'll just show you a couple of things. Alright, so I've done a few things like this here is, if we can zoom out, this here is for software design. Now, software design needs to learn the shapes and symbols of a system flow, and I thought the best way to do that would be to get this template, which is usually made out of plastic, and you buy these from, you can order these from Amazon. What you would do is get this, put it into the laser cutting software, and then you would print this. And what it would do is it'd actually, on say a piece of ply, it would cut this out, and then where these shapes are, they would be hollow. And what you would do is then you would be able to run a pencil around the edges of that on a piece of paper so that you could actually draw, say, an input or an output or a process. So these were designed on a computer using CAD, and then the CAM part of it is the computer-aided manufacturing part of it is actually printing this on laser cutter. Now this is the laser cutter software, and the name of our laser cutter is a VLS 3.50. I can print it on anything. So if I go into the settings and I go to the materials database, I can choose whatever I want. So for example, let's say I wanted it printed on plastic. I could choose, an acrylic where, I could have perspex, for example, and I could choose a particular perspex, cell cast, acrylic, or extruded, or continuous cast is most of the time what you do. So that would then be printed on its own piece of perspex if I wanted it to, or I could then go to, say, natural and choose wood, and then choose a type of wood, like I do MDF, in medium density fiberboard, for example. Or I can even do any type of thing. I could do glass, I could just do simple soda lime glass, or a fabric, or anything I wanted to. But that's just an example. I didn't actually print these ones. I decided that I would just simply purchase them because they were quite cheap to purchase in bulk, so I didn't print them, but I was going to just see what they look like. But yeah, I went with the originals and bought them. So and because they were only under $1 or something each, so it was pretty cheap. But that was a way of which I could actually use CAD and CAM. The video that you see here, I'm just going to pause it when it starts. Oh, I pressed the wrong button. The video that you see here, just want to pause it, is an example of a classic example of CAD-CAM, where it's actually a design of a Audi car, and this is a block of aluminium, and this rotating device here, like a drill, is actually drawing it. On the OneNote site, it is there. The Audi you can watch that on how it does the CNC machining from a CAD-CAM design. So that's a video that's I would recommend you watch, because it's quite amazing how shiny it actually gets it. Initially, it's I guess you would call it pixelated or well layered, and then it gets smaller tips of this drill, and then smooths it out. It's quite an amazing video to see. It also shows you the what the design looked like as far as a CAD design goes as well. Okay, so the next one is mail sorting. Now, with mail sorting, we need to be able to read handwriting, and the way that we do it is what's known as OCR. Now, OCR stands for optical character recognition, and in the OneNote videos I do have an explanation of what optical character recognition works, or you can just simply search that in YouTube and you'll get a couple of videos on that. I do have a video here on OCR and how it works. In a nutshell, imagine you had a sheet of paper that was, the entire sheet was a piece of text. What you could do is put that into a scanner, and the software on the computer that works with the scanner actually uses what's known as OCR, optical character recognition, to actually read the software, read the lettering and recognize it. So that's what OCR is in a nutshell. But a mail sorting automated manufacturing area, such as Australia Post, they can actually read the lettering on a envelope and know where the letter or the envelope actually has to go, or what the contents of the envelope, where it has to go, based on what the address is on that. So there's a video there, and then we have a video on the journey of a letter from Australia Post. I have put that on our OneNote. All right, so that's it there, and that talks about explaining how letters are recognised and where they go to. So it's a bit of an automated process, but it also has workers involved in the automation of sending a letter. And the textbook, of course, talks about, if we scroll down here, CADCAM, and then we move on to see mail sorting, and it says it uses OCR machines, and then we move on to reasons for automation. But that's a video that goes for a few minutes, so you probably want to pause me talking and watch that from the Prezi. Alright, so the next part of this lesson is the reasons for automation, and these are in simplified terms, and they're pretty straightforward. It's pretty common sense why there's the reasons for automation. So the first one is that repetitive tasks can be completed by robots or automation. When we talk about repeating something, it's because we have learnt from the past. In history, it states that humans don't really like to do repetitive tasks. They're not only for their health and well-being. Repetitive tasks become boring, and they lose interest and they lose morale. But also, you can probably realise what I'm talking about as far as injuries are caused. RSI is what's known as repetitive strain injury. It's done in typing. When we get back to class, I'll show you some examples of repetitive strain injury. And we also talk about it in the social and ethical issues of automated warehouses, where we talk about what RSI is, and you need to understand that that's a reason for automation, so that it eliminates that type of thing. The next one, of course, it reduces cost. In sense of the cost of labour is heavily reduced, but also when you buy products in bulk, you can reduce the cost, and that's why large shopping centres and large shopping chains. For example, I'm thinking of Bunnings at the moment, and you can think of how big Bunnings is. And the reason that Bunnings is so successful is because they can buy so many products in bulk that they can reduce the price of the individual item, and then of course the overall cost is dramatically reduced. And I'm sure that you've seen when you've gone to buy something, let's say you go to buy something on eBay, if you buy more than one of that product, then of course it's cheaper to buy two. And or we've heard the simple thing of just a simple raffle ticket. It's $1 for one. $2 for one, but then of course it's $5 for three. So that's a real simple way of reducing the cost, and that's in a nutshell how it breaks it down. Of course, productivity gains happen because you don't have human interaction to produce the product. Robots don't talk back, robots don't argue, robots just do their job. They have no emotions or feelings. They just do what they're required to do, and sometimes they are far more accurate than a human, and of course they can do it far quicker, and they can also deal with heavier weights as well, so productivity is increased. And then of course with automation we can look at certainly virtual models and how the automation process actually works. And then we move into, of course, the simulate. We can simulate what's being produced so that we don't actually have to create an entire manufacturing plant just to see what's going to happen in that manufacturing plant. And we can use software to simulate the production of a product and then actually go out and produce that product once the simulation has been done. But the last real main reason for automated manufacturing is, of course, safety. Now, the safety in terms of the human, it is a serious thing, like loss of life and things like that are a possibility, and of course that's really necessary for the consideration of automated warehouses. But we'll move into, as I mentioned before, when we move into the social and ethical issues of automated manufacturing systems, we will talk a lot about the health and well-being and safety of our workers. Okay, so you will now find that there is a homework task on our OneNote, and you can now go to that and hopefully you've written some notes down. I always recommend that you handwrite your notes because that helps you to learn the information that you're studying, and then you can go and complete the homework tasks. Enjoy.